Alright, this lecture is on series circuits. It says education makes children less dependent on others and opens doors to better jobs and career possibilities. So we are trying to take you and convert you from a series circuit to a parallel circuit. Now the goals for this presentation are that you understand the role of a fuse or a circuit breaker, that you be able to calculate the total resistance for a circuit in series, and that you be able to calculate at any resistor the power, the voltage, and the current at that given resistor. So a series circuit, we've talked about this before, very, very broad terms. The charge can only move down one path. It never has a choice. Removing one part of a series circuit disconnects everything from the circuit. That's all review. So basically what we're saying is if one goes out, they all go out. So if I were to take this bulb and this was to go out, all of these light bulbs would go out, even the ones before. So if this light bulb's unscrewed, this one goes out, they all go out, regardless if they're before or after. We talked about fuses and circuit breakers. We said they have to be wired in series because you really want to shut down everything that's after that so that you don't have an electrical fire. Resistors in series are also very useful when we talk about things like joysticks. A joystick has a metal slider that moves in, and what it does is it actually detects the difference in voltage, because remember we said the voltage is different whenever you have a resistor that is put into series. So that difference in voltage is detected and sent to the computer and goes, oh, hey, he's trying to move to the left. Or if you're moving it a diagonal, it's moving left and right. It goes, hey, or left and up. It says, hey, there's a really, really less voltage because you have these two resistors that are there. So it's actually very, very useful when we talk about things like that. Resistors in series. We said that they always increase. When you add resistors in series, the total resistance increases. It's actually very, very easy. Resistors in series, they always add. So if you have two resistors that are in series, whatever value they have individually, you add them together, and that's their total resistance. It's a very, very easy formula. So if you have two resistors, you add the two together. If you have 50 resistors, you add the 50 resistors together that are in series. Now current is a little bit different. It's the same throughout, but you have to be able to calculate it. So you have to have either the total resistance, and then you have the voltage, and you can figure out what the total current is. The reason why the current has to be same is the law of conservation of charge. It must have the same amount of charge no matter what. It's not like you can have 10 coulombs of charge in one resistor, but only 1 in the next resistor that it has to go through. So because of the law of conservation of charge, the current in the series has to be the same no matter what. Voltage, however, is going to drop. Whenever you have a resistor is like something that's pushing back. So if you have 1.5 volts here, this resistor right here is going to push back. And so when you get past it, you're no longer going to have 1.5 volts. Now, whenever you're calculating the voltage drop, which is going to be very important, it's just Ohm's law. The voltage drop is going to equal the current times the individual resistor. So whatever current is here times this individual resistor. Everything is defined as if this has 1.5 volts, this is going to have 0 volts by the end of it.